if there's no more questions. Good. All right, let's hear about CBD.
Thanks, Stephanie. Good evening, everyone. My name is Simon. I'm a postdoc fellow in Dr. Richard Chen labs at NYU. And tonight I'm really happy to tell you about my research. We started this project about 2 years ago, aiming to understand how does CBD modulate information transfer in the brain. But before I tell you more about my research, I'd like to introduce you to Charlotte Figi. Charlotte Figi is pictured here. She's a 7-year-old kid. She's doing obviously really well, but this had not always been the case. Charlotte experienced her first seizure when she was only 3 months. At 2 years old, she was diagnosed with Dravet syndrome, which is a rare form of intractable epilepsy. And intractable in this case means that the traditional medication will not help her at all. Everything went downhill from there. At 5 years old, Charlotte was having up to 300 grand mal seizures per week. Her parents were told by the doctors at the hospital that there was almost nothing that they could do to help her. She would be just basically lying in a wheelchair, having all of these seizures, and there was nothing doctors could do to help her. So our parents were pretty much desperate, and the Figis were strongly opposed to medical marijuana or any form of legalization of marijuana for that matter. But her father, who is pictured here, went on the internet and saw that medical marijuana could do miracles for children with Dravet syndrome. And these people who were strongly opposed to marijuana eventually decided to try it on their kid. It was like a last resort measure. Now, the first hour after they gave medical marijuana to Charlotte, she had no seizure. She would usually have up to 3 or 4 seizures per hour. The first week after they began to treat her with medical marijuana, she had no seizure. She was actually experiencing up to 300 seizures per week. So what happened? How did medical marijuana help Charlotte in this case? I must tell you that Charlotte Figi was taking a special strain of marijuana, one which is highly enriched in CBD, cannabidiol, and very low in THC. It is a strain actually called by her name. The strain of marijuana she was using is called Charlotte's Web. Now, in cannabis, there are up to 100 compounds called cannabinoids. But the 2 main compounds that are found in cannabis are THC, tetrahydrocannabinol, which is the compound that is psychoactive. It is the compound that when we smoke marijuana, this is what makes us high, makes us happy, makes this like kind of warm feeling, and it's also the compound that gives us the munchies. Okay, so unfortunately I do not have an interactive exercise as Stephanie had. Another major compound found in cannabis is CBD, cannabidiol. Up to now, we did not really know what it was doing, but reports like Charlotte's story started to pop up on the internet, like several tens or hundreds of anecdotal reports like this, which sparked strong interest in CBD. But you do not convince scientists or medical doctor that CBD can cure epilepsy by doing a Google research or looking up some information on Reddit. You actually need to present them strong facts, and to do that, strong facts in medicine are usually obtained through double-blind placebo-controlled studies. Essentially, a double-blind placebo-controlled study is a study that they will take a cohort of patients, they will split it in 2. One half of the patient will be given a placebo, the other half will be given cannabidiol. And they will compare the effect of the drug, of cannabidiol, versus the effect of the placebo on the number of seizures. The first double-blind placebo-controlled study on cannabidiol came out in May 2017 by Dr. Oren Devinsky. What they found was that CBD caused a large reduction in seizure frequency in patients suffering from Dravet syndrome, and that this effect of CBD was significantly better than the placebo. A second study came out in the spring of this year looking at another disease called Lennox-Gastaut syndrome, and they also observed that CBD caused a reduction in seizure frequency of up to approximately 40%, which were very, very good results because these patients have basically no other resource. The traditional medicine do not work on them. And this reduction in seizure frequency of approximately 40% is in the range of most other medicines given to other patients. So, coming back to my research, how does CBD work to dampen brain activity? Stephanie was using the analogy of a chant in a crowd to explain this, a very synchronized activity, electrical activity that is observed in the brain of patients having seizures. And we wanted to look at the level of single neurons. How does CBD modulates the activity of single neurons? Here's a picture of a real neuron that was recorded in a mouse brain and that was stained and for which we can observe the morphology. Neurons are composed of a cell body and they have this extensive dendritic arborization where they receive inputs from other cells. That's how they communicate with each other. Neurons are also electrical cells, and when they are depolarized sufficiently, they will fire an action potential. You can picture this, the action potential, as the fundamental unit of communication between neurons. It's, let's say, words that we use in sentences. And in highly synchronized epileptic brain activity, we can track multiple of these action potential in close succession at a high frequency across multiple neurons in the brain. And it's very important that there are two types of neurons in the brain, just generally speaking. Neurons which are inhibitory, which release the neurotransmitter GABA, and who will oppose the propagation of action potential from a neuron to another. The other type of neuron are excitatory neurons, which release glutamate, and which will propagate the action potential to the next neurons. However, what happens in epileptic brain is that there's a strong shift in the balance of excitation to inhibition towards excitation, such that this pathway of propagation of action potential is highly favored. So most anti-epileptic drugs do one of two things. They either increase the efficiency of GABA to reduce propagation of activity, or they either decrease the efficacy of glutamate to propagate activity. So we started from this idea to ask, how does CBD work? And our experimental model are acute hippocampal slices obtained from brain mice. These are brain slices that are kept alive on which we can do experiments. And we specially selected the hippocampus because it is a brain region that is affected in several patients suffering from epilepsy. Hippocampal slices present this advantage that we can observe them under a microscope and place electrodes strategically to stimulate axons of neurons so that they will release neurotransmitter on their postsynaptic cells and directly record the electrical activity in the postsynaptic cell. So the first set of experiment that we did was to record from excitatory neurons. We can visually see them under a microscope, and we can put an electrode in them and record the electrical activity that goes through the membrane. In control condition, we observe that when we stimulate repetitively the axons, such as to mimic what would happen in a kind of epileptic activity, a large, synchronized, and high-frequency activity, we see that we can generate these action potentials. But after the application of CBD, we observe that these action potential are mostly gone, or in this example, are fully gone, suggesting that CBD decreased the activity of excitatory neurons. The same experiment can be done in inhibitory neurons. But in this case, we saw the exact opposite. The activity of inhibitory neurons was increased by the application of CBD compared to the control condition, indicating that CBD also increases the activity of the inhibitory neurons. So our results led us to think of this model. And I must tell you that CBD by itself had no effect on the resting state activity of the neurons. It only had an effect when neurons were stimulated at high frequency. So we came up with this concept to explain our result, that CBD acts to increase synaptic inhibition on demand in the brain. So what does that mean is that in a disease brain, activity is very well propagated to the excitatory neurons by the afferents. But if we treat this brain slice or this brain tissue with CBD, what we observe is that the inhibitory neurons will be recruited and its timing will block the propagation of activity to the excitatory neurons. So this mechanism is pretty unique. Let's say by analogy, if you wanted to stop, if you were driving a car and you wanted to stop it, well, the best way to do it is to remove your foot from the accelerator and press on the brake at the same time. And pretty much that's what CBD does. And when we look at other anti-epileptic drugs, this mechanism of action is pretty unique. There's no other single drug on the market that acts on both inhibition and excitation at the same time. Now, the status of CBD to treat epilepsy is maybe not as not applicable to all types of epilepsies. At the moment, it has a demonstrated efficacy in 2 types of disease, Dravet syndrome and Lennox-Gastaut. So at the moment, CBD is FDA approved for the treatment of Dravet syndrome. Epidiolex, which is produced by GW Pharmaceuticals, is a pure cannabidiol. Now, if we want to understand more about how CBD can help patients with epilepsies, more clinical studies will be required. Of course, there are anecdotal reports on the internet that says, let's say someone reports that CBD cure is anxiety or whatever, but clinical studies and like double-blind placebo controls will really be required to demonstrate efficacy in different types of disease. And this should be favored by the fact that CBD has a very low likelihood of secondary effects in these clinical trials I was showing you before. Basically, the main secondary effect that is observed in patient is sleepiness or a little bit of drowsiness, but that's it. So thank you for listening to my research. I'm really happy I could tell you about it. And I think we'll have a little break, and then Elisa will tell us about her experience.